Why can't I move everything up? What's that? Okay, wonder why that's the case. There we go. I use little arrows to move it up, hit fit. Alright, so I've got something that's very useful now. So I'm going to do your homework assignment that's for Wednesday using the standard cell frame. Okay, you don't have to do it that way, but I'm going to do it just so you can see a different way. Okay, you know what I'm going to do just to verify it LVS is alright. I'm going to make an inverter and see if it works. So let's go ahead and do a control N and do a layout, or let's do a schematic, which is an inverter, or let's just call it inverter 20_10, and I'm going to drop my PMOS, my NMOS in here, do a control I. How do I set the spice model here? Just for the future. Tool, spice, set spice model. Then I do a control I on that, and I'm going to call it NMOS. And I'm going to make it a little smaller, 0.5. Move it over. And I'm going to drop my PMOS, just in case you want to get fancy and start doing sims, because I'm going too slow. And then we'll drop a ground in there, connect that up, fit, then a power, expand, put that over, pull that down, connect these two together. This is an inverter. Of course, we don't know what that means at this point. Off page, you just know how to copy the schematic. I'm going to select that port and do a control I, and control E rather, and call it in, and it's a input. And here, control I, past performance is a good indication of future performance. Output, and it is out. Or you might go, let's be a little different. Let's go this control I. Well, that should work. Control I, right? Now I guess I got to shift through. Control I. Call this A. And then control I. And A I. Or A bar. Or A not. Okay, let's go AI. Okay, then I got to go up here. Control I. 20. Let's not forget to set the spice model. So once you set the spice model, it's good to copy stuff. You say Tool, Spice, Set Spice Model, Control I, PMOS. You have to set it to whatever, and I think I set it to 1/2 on the other one. Fit. Let's see. Now let me show you one thing that might be useful. We do this semester a charge pump project, which is a charge pump is something for generating voltages outside the power supply range, and so you can't have your wells at VDD. They have to flow higher. We go to a higher potential. Charge pumps used in programming Flash. If you select this and go to change and change it to a 4-port transistor, it puts or selects this bottom node as the source instead of the top node. And so if you want the source connected to the substrate, you have to flip the symbol around when you look at it in the net list. It's not a big deal, but you end up pulling and moving these up, and it just clutters the schematic instead of having it flip the other way. Now I'm going to make a mistake here. I'm going to select this cell and I'm going to go change. I'm going to change it back to a transistor. Oh, it won't. The reason is it's because I have these connected. If I go back and hit change, transistor, apply, then I'm done. Okay, easy, right? Now, let's do our layout. Control N. How are you finding electric anyway? Easy? Once you know it? Yeah, just like everything else. Okay. Okay, so what I'm going to do now is I'm going to go to my Excel and I'm going to drag in my standard cell frame, which I can't do because I've got too tiny of a window here. And where did I put that? There it is. Let's drag it in there. Oops, let's show that and hit fit. Now I'm going to put in a NMOS node and do a Control I, 10 by 2. Now I have to set the spice model for this one too, so I go up and hit spice. Now you know why I'm doing this, so later when we come back to this, I'll be able to use this cell without redrawing it. So let's set spice model. Now notice I can't see anything, so I'm going to zoom in down here, click on that, do a Control I, NMOS. That says this model is an NMOS. Hey, while I'm here, I'm going to go, I can do this one of two ways. I can drag it down like that, and that's connecting active over, okay? Or, what else could I do? I could go like this. Whoops. Oh. Wonder why it's not letting me connect. Whoops. Let's do this. Now let's cycle it through. Yeah. Well, no, I just hit the shift and then I come down here like that and then go to metal. Then I can come over. Now, you know what? I'm seeing an issue with the standard cell frame, which we'll fix. Okay, oops. So let's go. Let's fix this issue first. What's that? Yeah, so there's a port on the NMOS that you can just drag over, but I'm fighting with the standard cell frame, so what do I do to fix that? Um, yeah, special select. So if I hit Control I and I hit attributes and I set, let's see if it was on the previous one. So easy to select, I unclick. That's the thing I'm fighting with. It's so easy to select, it keeps selecting instead of what I want to select. So I'm going to go hit OK. Then I'm going to come down here to my NMOS, drop my, oh, I did all that unnecessarily. Well, we'll just connect it up. And then I'll go over here. Oh, I didn't want to do that. Control Z. Let's see, what can I do here? I can drop my contact in. I can come down. Well, now it's not letting me select at all. And connect there. Yeah, maybe I'm not too hot on this now. Because it's not connecting up. Anyway. It should connect up to that port. Well, it looks like it's connected now. No, it's not. Oh, okay. All right. There we go. All right, so what's the point of doing this, though? And we can come up here and put our, let's do a Control I. Yeah, and then when I line them up, well, we'll finish this since it's fast. PMOS, and then zoom here, and then let's do a control I, a 20, and we can put the splice models on. Let's go ahead and drag this, expand, drag this down, make a connection like this. Well, you know what, I don't like that. Yeah, we'll just see what happens. 22 errors, I knew that that wasn't good. So we'll delete that. We'll come up here. Nope. I'm trying to avoid not using the P active, but we'll use it anyway. Come over here. Come down. Nope. Come down. There we go. And then come over here. Let's do P active again. And come down. And then go up to, oh. Yeah. Okay. Now, this is an ugly layout. What do I do to fix it? Restart. Move this down. Do a control I. Change this to 15, apply or so, whatever. You can mess with that later. And you can set the size and pull this closer, etc. Fit. Why does it do that? Anyway, so let's go put our pins here. And then I'm going to export this one, Control E, which is AI. Then I'm going to connect the polys together. Then I'm going to put a connection here. And then a zoom. Control E. And that's an input, and we'll call that A. Any questions? Yeah, you can move this like this one. Well, you can move this up. This is P plus and this is N plus. So, yes.
Ideally, if that will switch together.
Yeah, the problem with using a standard cell frame is you blow out your layout area. So, but the benefit I'll show you in just a moment is you can line everything up. Yeah, it's well worth it when you actually go to do things. But I'm not done here yet because I need to also put in pins for my power and ground. And again, I'm going to be sloppy and just do it fast. I'm going to export that, Control E to VDD. Because I have connections to the standard cell frame, but I don't have them to this cell. Okay, so I'll go down here and drop that in. And then select here, Control E, GND. Okay, and then I can move these over where I make my connections to the cell, and I might want to label that with text. And let's see how many errors we have. So let's see here, ground is implied in my schematic, and in my layout there's actually a ground and VDD port. That's just that's not a bad error. I mean, it's implied, so it's not bad. It's not a failure, but I want to make it so everything works without any problems. So I'm going to go fix this. But before I do, are there any questions? Yes.
Since we want to be using this inverter later on, what size frame?
I think this is probably a reasonable size. I think I might flip the orientation of the NMOS and the PMOS so they're up and down. But if you use this size, and when you go to a NAND gate or something more elaborate or a bigger inverter, you don't have to make this too much bigger. What the key thing is, if you need more area, what do? You just take these cells and put them end to end until you get the area that you need for your PMOS and your NMOS. Okay, all these little layout tricks that are really important to save time. So, did that make sense? Question?
So you said you were going to explain why you dropped the middle pin. When I made my inverter, I didn't make the standard cell, but I exported the node into the VCC as opposed to made a pin and then a pin to it.
The
Then
reason
I used it in a higher level cell, then it was connected.
the reason I did that is this node isn't really in this cell. In fact, if I go here and I close it, I don't have a node there, so I can't export it. So I have to make.
I understand why you did this cell, but not to the standard cell. Why you did it?
No, you could do that.
Oh,
Yeah, you can do that. Yeah. The reason I did it that is just like this. I want to be consistent, and if we learn to do things the same way over and over, fewer pain. Okay. All right. So let's show that. Let's go fix this and get it purely LVS clean. And our